Okay, so a sub n minus 2 is 2 terms before. A sub n plus 3 would be 3 terms after. And n plus 100 would be 100 terms after. All right, so one more time. 19 should be 2, 24, 720, 40,320. 22 should be 1, 2, 3, 4. So b sub 1 is 1, b sub 2 is 2, b sub 3 is 3, b sub 4 is 4, and finally 25, your end result should be 3n plus 1. After going over those, do we have any questions? Awesome. Wasn't expecting the thumbs up, but I love it. All right. Today we're going to get to something called arithmetic sequence, which is nice. So when I just talk about sequences, it is a broad stroke. There's tons of different sequences we can use with factorials and stuff. The nice thing about arithmetic is we're going to reduce it down to one type. And this one type, arithmetic, is really one of the easiest types, and it is just you're adding or subtracting by a number. So think of like 2, 4, 6, 8. I'm adding 2 over and over and over. So with arithmetic, you're only adding or subtracting. And the easy way to put that is it's just a sequence that has a common difference. A common difference. And that common difference is adding or subtracting a number. So if we look at the sequence down here, I start with a number, and I add some number to it. So it's a sub 1 plus d. Then I have a sub 1 plus 2d. Then I have a sub 1 plus 3d, 4d, 5d, so on and so forth. You're just adding a number over and over and over. Your big thing is coming up with what this number is. And the easiest way to come up with your common difference is, usually it's pretty easy. If I go like 2, 4, 6, 8, 10, you're just like, oh, there's 2 between it. If you ever get stuck, you can always subtract any term from the subsequent term to find the common difference. In other words, take your second term and subtract your first term. So 5 minus 1 is 4. They all have to have 4 between them. These are pretty easy. You can either see it or you can do the subtraction. Usually you don't need to do the subtraction. Maybe if you had fractions, maybe you would. But otherwise, you can usually just see the pattern or not see the pattern. So the first examples are, we're just supposed to determine, are these arithmetic sequences? If so, we're going to state the common difference. Now, for common difference, we're just going to use a lowercase d. We're going to say d equals something. So in order to have a common difference, every one of these must be the same distance away from each other. So what I'm looking at is, I'm looking for addition. So to get from 1 to 5, I would add 4. As soon as adding 4 gets me to one of them, I must add 4 to all of them, and it has to work. So 4 to 9, that's plus 4, that's good. And 9 to 13 is plus 4, so that's good. We're going to assume the dot, dot, dot means that that is going to continue. So this is, in fact, arithmetic. It is arithmetic. And our common difference, our d, is going to equal 4. Those are the two things he asked. Is it arithmetic? Yes, it is. Come up with your common difference. It is 4. When you have fractions, just remember, to add fractions, you have to have a common denominator usually. If you're doing it right, you need a common denominator. So if I'm checking to see if this is arithmetic, I'm going to make sure they all have a common denominator. So I'm going to rewrite this sequence. It looks like we could make a denominator of 6 from all of them. So we're going to turn 1 into 6 over 6. We're going to turn 7 over 6. We'll leave that as 7 over 6. We'll turn 4 over 3 into 8 over 6. And we'll turn 3 over 2 into, I guess, 9 over 6. This really preps us for Monday more than today, but we're going to have a common difference. To get from 6 over 6 to 7 over 6, you are adding 1 over 6. Here we are adding 1 over 6. Here we are adding 1 over 6. It is arithmetic. And our common difference is 1 over 6. There's an alternate way to do this one, and we'll talk about that on Monday. And that is dealing with the fact that we do have a sequence on top. We have a stagnant sequence on bottom. We can treat it as 2, but for today, our common difference is going to be 1 over 6. All right, our last one. The difference between 1 and 4 is 3, so I would add 3. To get from 4 to 9, I can't just add 3. I have to add 5. You do not need to go any further. This is not arithmetic. It must be adding the exact same term over and over and over, so as soon as it changes once, you don't have to go any further. Even if it went back to 3 the rest of the time, if this would be plus 3, plus 5, plus 3, plus 3, plus 3, plus 3, doesn't matter. That plus 5 means it's not arithmetic. Down here it says write the first 5 terms of the arithmetic sequence. You are given your first number and you're given your common difference. So that means you write down your first number, which is 17. And to get to my next number, I just subtract 3. The common difference is minus 3. So 17 minus 3 is going to become 14. So we are subtracting 3. Then we're going to keep subtracting 3. Already forgot how far I have to go. Is 5 enough? What did it say? Write the first 5 terms? Cool. I got my first 5 terms. 17, 14, 11, 8, and 5. So what I want to point out with this one problem, the most important thing with an arithmetic sequence is what is your first term and what is your common difference. If you have those 2 things, you can do everything we're doing today. Everything we're about to do, you can do as long as you know those 2 things. So that's what we're going to start with. And we're going to start with writing an explicit formula for any arithmetic sequence. Now, if you remember from yesterday, our explicit formula is the most important. I find it is the most important formula because it is the one where I can say find the 25th term, and you don't have to add 2 to everything over and over and over. So if I ask you to find, the 30th term on here, that would take a long time because you have to keep subtracting 3. I guess you can go in your calculator and just do it. But if I ask for the 1000th term, you're going to struggle with that. At that point, you need to come up with an explicit formula. To come up with an explicit formula, all we need to know is the first term and your common difference. And this is going to be your equation. Your equation is going to be a sub n. So the term you want is going to equal the first term plus n minus 1 times d. This will always be your first term. This will always be your common difference. This n is just based upon what number in the sequence you're on. Think of this as being your x in your equation. To have this equation, you must have a number for a sub 1. You must have a number for d. That is your x in your equation. I am going to note, you can simplify this, and we will simplify this. So once we get these values, we're going to distribute, and we're going to simplify this to like 3n plus 1. It makes it a lot easier for you to see that equation. All right, but that is our explicit formula. Now, what we're supposed to do is we're supposed to determine whether the sequence is arithmetic. I bet it is, because we have to write an explicit formula. And then we have to write an explicit formula for it. Now, your 2 big things you need are your first term and your common difference, and you have yourself an equation. So let's first check to make sure it's arithmetic. To check for its arithmetic, we have to make sure it's plus 4, it's plus 4, it's plus 4, it's plus 4. Cool, it is arithmetic. As soon as I know it's arithmetic, what I'm going to do is I'm going to say, okay, my first term equals 3. My common difference equals 4. Those are our 2 big things that we need. Now we're just going to plug it into this equation. So we're going to go with a sub n equals, well, my first term is 3, so we're going to plug a 3 in for that a sub 1. Plus, the n is our x value, so it's going to stay. It should be n minus 1. And our common difference is 4. So that is our equation. Now we're going to go ahead and simplify it. By simplifying it, we're going to distribute this 4 to everything. It goes really quick once you start getting used to it. I'm going to do the long way. The long way is actually to write it all out. So we have 3 plus 4n, because we're distributing this 4 to both items, minus 4. 3 plus a minus 4 is going to equal 4n minus 1. I strongly suggest you check this on the test. Easiest way to check it is don't take your first term, take like the second term, the third term. Your third term should be 11. What that means is if I plug a 3 in for this n, I should get out 11. Plug a 3 in. We get 4 times 3 is 12, minus 1 is 11. Okay, good. Maybe I'll check another one. 1, 2, 3, 4. My fifth term should be 19. 4 times 5 is 20 minus 1 equals 19. They're really easy to check. Just plug a couple numbers in and make sure it matches this. It's very easy to make little mistakes, so just check it on the test. It's a really easy check. All right, that's arithmetic sequence, explicit form. The next one we're going to talk about is a recursive form. The recursive form, I'm going to add some stuff to it, and I'll say what's important and what's not really important to it. So our recursive formula for an arithmetic sequence with a common difference d. To have a recursive formula, remember from yesterday, a recursive formula is basically you take the term before it, you do something to it, you have your next term. Next term is do something to that term, do it before it. So you need to have a starting point. You need to have a starting point, and I'm going to do it like this. A sub 1 is going to equal some number. So we need to start out by coming up with what's my first term. Now, our equation is going to be, make sure I didn't miss anything. I did not. Okay, our equation is going to be the term you want is going to equal the term before it plus your common difference. Remember, we just keep adding a number over and over. So this will be plus your common difference. You need to have this. You need to have this to have a recursive formula. There is something off to the side I'm going to put on there. You do not need to include this. Basically, your n has to be bigger than or equal to 2. That way you can go, okay, my second term would equal the first term plus my common difference. You do not need to write this. This is the important thing. This is basically taken for granted that we're going to start at our second term. That I already gave you the first term. Your job is to get to the second term. Not needed, but it's implied that that's happening. All right, so now we have determined whether each sequence is arithmetic. If so, write 2 formulas. 2 formulas means we're going to write a recursive formula and we're going to write an explicit formula. I bet it's arithmetic, otherwise I probably wouldn't have given us room to do both of those. So let's make sure it is arithmetic. To make sure, we're going to see, okay, from 3 to 2 is a negative 3. Negative 3, negative 3. The most important part about an arithmetic sequence is coming up with your first term and coming up with your common difference. If you have both those things, you can come up with a recursive and explicit formula. So if I just gave you those 2 things, you don't even have to see the formula. You can write these 2 things from it. All right, our recursive formula. For a recursive formula, we have to start by writing our a sub 1 equals our starting point. Do not forget this. This is an important part of our recursive formula, telling the person where to start. I'm starting at the number 5. Now is where we actually write our formula. So our formula is going to be a sub n equals a sub n minus 1. So the only thing we're adding on is the negative 3. So it'd be minus 3. So our job in the recursive formula is really to figure out what our first term is and what this d value is. Otherwise, this stays the same. The easy way to remember this is just the term you want equals the term before it minus 3. That's why we're practicing saying that. So if you just remember the term I want equals the term before it plus d, that's an easier way to remember it. Our explicit formula from the back says, okay, a sub n equals our first term. Our first term is 5. plus, now that n minus 1 is going to stay, and the only thing I'm going to add on to it is the d value, which is a negative 3. So we're multiplying by a negative 3. Maybe I should put that in parentheses. All right, let's write that fully. So that'd be 5. Now, when I distribute this negative 3, that n turns to a negative 3n. When I distribute it to that negative 1, it becomes a positive 3. So this is going to equal a negative 3n plus 8. I'm always going to check to make sure it is correct. So to make sure it's correct, I'm going to plug in one of those things. So maybe pick the third term. Third term needs to be negative 1. Well, negative 3 times 3 is negative 9, plus 8 is a negative 1. This is correct. Don't skimp on checking it. Just check it. Just check it. Don't make stupid mistakes. I already see on my guide, I already had a mistake on there that I caught right now. All right, the last one is probably the hardest problem. The following is an arithmetic sequence. So they told you it's an arithmetic sequence. It says write 2 formulas to model the sequence. The problem is they don't give you the first term. They give you the third and the 6th term. So what's happening here is we have a sequence. You don't have to write this out every single time, but I'm just saying what's happening. So we have a sub 1, a sub 2. We know our third term is 15. We don't know our fourth term. We don't know our fifth term, but we know our 6th term is 36. And this is going to go on forever. Okay, so real quick. So we know the third term. We know the 6th term. The first thing I want to get is what's the difference between 15 and 36? So how much did I change? How did we get from 15 to 36? How many numbers are between those things? So we just got to do 36 minus 15. There are 21. To get from 15 to 36, there's 21 numbers I have to cover. So I need to get from 15 to 36, so I have to add 21 with basically 2 steps or 3 steps. So I got to go here, here, and get to there. So the next thing I want to know is how many steps did I take? Well, the easy way to do that is just to go from 3 to 6. That is going to be 3 steps. To get from 3 to 6, we have go to 4, go to 5, go to 6. So in other words, it's 6 minus 3. We have 3 steps. This right here will get us our common difference. Your common difference is going to be how much ground did you cover in how many steps. So our common difference is going to be 21 divided by 3. What 7 is basically if I take 15 plus 7, plus 7, plus 7 again, I'll get to 36. So the number between 15 and 36 divided by how many steps it takes to get there will tell you what your common difference is on the entire scale. All right, so that's an important thing. Our common difference is 7. The next thing I need the very first term. There's 2 ways to do it in this problem. First way is, once you know the common difference, we can just subtract. I could subtract 7, and I can get to 1. The problem with that method, so like I said, we could subtract 7, that would get me a sub 2 is 8. Subtract 7, a sub 1 is 1. The problem with doing that, what if I give you a sub 100 and a sub 103? That means on a test, you're going to be subtracting 100 times to get to your first thing. So it's not the most efficient method. The most efficient method is actually going back to the formula. So we already have our D. I'm going to cover that up. In this little section, we're going to find our a sub 1. And the way we're going to do that is we're going to write our formula. So remember, our explicit formula is a sub n equals a sub 1. So a sub 1 is already in there. Plus n minus 1 times d. Now, we know the common difference is 7. We also know the third term is 15. So what we're going to do is we're going to plug in as much information as we have. So what I'm thinking about is, well, I know the third term. So I'm looking at a sub 3. A sub 3 would equal a sub 1 plus 3 minus 1 times our d value, which is 7. I got more I can put on here. A sub 3 equals 15. So I can take that 15 and plug it in for that a sub 3. So we can go, okay, 15 equals a sub 1 plus, well, 3 minus 1 is 2. 2 times 7 is 14. Subtract 14 on both sides, and we have our a sub 1 equals 1. That is the easiest way without actually subtracting to get your a sub 1. Once you have both of those, you have your recursive, you have your explicit. Recursive starts with a sub 1 equals 1 in this case. And then we'll have a sub n equals the term before it. And we plus our common difference of 7. Your explicit is a sub n equals your first term, in this case it's 1, plus n minus 1 times the common difference of 7. Simplify that, you should have 7n. 7 times a negative 1 is negative 7, plus 1 is going to be plus 6. Now you have a hard time checking your recursive, but you have an easy time checking your explicit. My third term needs to be 15. Oh, I missed the negative. It should be minus 6. It should be minus 6. That's why you check it. This should be minus 6, could be a negative 7 plus 1. All right, 3 times 7 is 21, minus 6 is my 15. That worked out. My sixth term should be 36. 6 times 7 is 42, minus 6 is going to be that 36. That works. That is my explicit. That is my recursive. I am done. That is probably the hardest problem you have with arithmetic sequences, where they don't tell you what the first term is. All right, but in a nutshell, that is your arithmetic sequence.